Hello students, and welcome to our third video here for calculus. Up until now we have introduced this exponential function y equals e to the power of x, and e itself being approximately 2.7, and we looked at transformations of the graph of the exponential function. But today we want to differentiate the exponential functions and variations on it, and in almost every case we're going to use the chain rule. We'll quickly learn an abbreviated form of that works really well with exponential functions. Right? They're a very good match, the chain rule and exponential functions. In fact, in many ways, it's why the exponential function is so helpful to us, because of the way that it works with the chain rule. So let's have a look at this one here. Y equals e to the power of 2x. We know the derivative of y equals e to the x is y equals e to the x. So I use a substitution to produce a function that looks a lot like that. Now if u equals 2x, then my function will be y equals e to the power of u. I can differentiate that very easily with respect to u. It's just y equals e to the power of u. And substitute back into that, and dy by du is e to the 2x. I also need to differentiate the substitution, which is really quite simple. The derivative of that will be 2. And the chain rule tells us that dy and dx is du and dx multiplied by dy and du, which is 2 times e to the 2x is 2e to the 2x. Now I'll tell you this, and this is going to work for us generally, is the derivative of an exponential function is the derivative of the exponent multiplied by the original function, or the function multiplied by the derivative of the exponent. Rightio, 2e to the 2x. This here is a bit more complicated because it's written in fractional form and with roots. If I rearrange that using my index laws, I could say that y equals 5e to the negative 1/3 x. Now in that form there, it's much easier for us to use the chain rule and this rule for differentiating exponentials. So my substitution again is going to be the exponent, that's negative 1/3 x. Now I can differentiate my function with respect to that substitution with respect to u, and I get 5e to the power of u, substituting back in 5e to the negative 1/3 x, which is the original function. And that's going to happen over and over again if we use this sort of substitution. Differentiate the substitution as negative 1/3, and then the chain rule tells us that I multiply those two things together. So I get negative 5/3e to the negative 1/3 x. Coming back to that abbreviated rule here, back over here, once I've written my function in this sort of form, e to the power of x in some sense, the derivative of this is a negative third. Multiply that by the original function, so it's negative 5/3 e to the negative 1/3 x. Okay, and while you should practice using the chain rule from time to time, you're quite welcome, it's quite acceptable to use that shortcut, if you like, that abbreviated form of the chain rule, particularly when we're doing exponential functions. Okay, that only works with exponential functions with a base of e, but it does work very efficiently for us. That's it. Differentiation of exponential functions. Just quickly to go over those things: to differentiate an exponential function, multiply the function by the derivative of the exponent. Okay, all good. That's it for now. Next up, we'll be looking at the geometry of the exponential function and its derivative. Right, we'll just be sort of doing some exercises applying some of these things that we've learnt so far. But if you've got any questions about today, about differentiating exponential functions, make sure you jot them down so you don't forget. Shoot me a message or ask me in class. See you there.